Here we have question 3 from chapter 2 revision exercises. So we have 2 points P and Q, a distance d apart, so let's sketch that. P and Q are a distance d apart. Q has initial velocity and is moving, particle starts at P. P has initial velocity of 2u moving towards Q, so we've u is equal to 2u, and a second particle starts from Q and moves towards P at the same time with initial velocity 3u. We have uniform acceleration of f for particle P, and for Q we have deceleration because it's traveling in the opposite direction. We have acceleration of minus f, and we're asked to prove some things here. The particles collide, so we're looking for time here. Time is equal to this guy. So what can we say if they collide? Well, if P is going in this direction, no matter where they collide, the distance traveled will be d. So S1 plus S2 is equal to d. So let's look for S1, the distance traveled by P. Using the formula that you've used 1,000 times, S is equal to ut plus a half at squared. We get 2u for P, 2ut plus a half f by t squared, and the distance travelled by Q will be 3ut, and it'll be minus f, so minus a half f t squared, and these two things added together will be equal to the distance travelled. So we're going to get 5ut, the ft squares will cancel, so we're going to get the time will be equal to d divided by 5u, which is what they were looking for, d divided by 5u. So in the next part we're told, or we're asked to prove, if the particles collide before the second particle comes to rest. So what are they trying to tell us here? Before it comes to rest, its velocity will be greater than 0 if it's just before it comes to rest. So the velocity of the second particle Q will be equal to u plus at. So this velocity has to be greater than 0. So the velocity 3u is the initial velocity minus f times time, which is d over 5u, will have to be greater than 0. So 3u will have to be greater than fd over 5u. And if we cross multiply, we get 15u squared is greater than fd. And they want fd less than, so we just reverse it around. That would mean that fd would be less than 15u squared, which is what they're looking for up here. So that's part 2 correct, part 1 correct, and part 3, if fd is greater than 30u squared, then the second particle has returned to Q before the collision. Well, if it has returned to Q, what has happened? This second particle goes in this direction and then goes back to here. The distance travelled will be equal to 0. Negative distance in the opposite direction will get a negative answer, so it has returned to Q. So let's look at the distance in Q will be less than or equal to 0 if it's returned to Q. So S of Q is equal to ut plus a half at squared. So we're using the same information again. We have 3u and we have time this time, which is d over 5u, ut plus a half times minus f times time squared, so that's going to be d squared over 25u squared, and this will have to be less than or equal to 0, and we want, do we want fd on its own on the left? Okay, so we'll get that in a second. So we're going to have, well, this simplifies, we're going to get 3d over 5. If I bring this expression to the right, that will be less than or equal to fd squared over 50u squared. cancelling or dividing across by d, we'll have d and the squared part will cancel, and if we multiply by 50, we'll get a 50 here and a 50 here. That will cancel with that one, so we're going to get 50 divided by 5 is 10 times 3, 30 is less than or equal to, we're going to get fd over u squared, so 30 u squared will be less than or equal to fd, and we want fd on the left, so we need to reverse the symbol. Fd will be greater than or equal to, it just says greater than up here, we have greater than or equal to 30 u squared. Then we're asked to conduct a dimensional analysis on the last part here. Fd is acceleration by distance. Acceleration is ms to the minus 2, or m over s to the power 2, and distance is in meters, so the dimensional analysis on the left is going to be m squared over s squared. On the right, 30 by u squared, well 30 is a constant, 30 by u squared, so u is meters per second, so u squared is m squared over s squared, so we can knock off the constant and we can say that the dimensional analysis matches up m squared over s squared on both sides.